you can click on stock setup button. So this is the rectangular plate. So our raw material size should be in a rectangular plate. Okay. So you can just click on the bounding box button. See, in this window there is bounding box button. You just click on bounding box button and select the component and press enter button. So it will show the optimum required raw material. So now the blue line in the blue shaded region indicates the optimum raw material required for this component. So if you want extra raw material, you can add in the size given in this window. So 12 mm. So I have added here 17 mm. Okay. So you can add here 14 mm material, because 2 mm material removed from the facing cut. Okay. So just click on done button and click on the OK button or done button. So now see in the front view. So this is 2 mm material extra. This red line indicates raw material size. Okay, and this 2 mm extra material for facing operation. Okay. If you want extra material from the side edges, you can add that. You can add 50 mm in the y direction. You can add 50 mm in the x direction. So see. Now the next step is, see in top view. Now we can perform operation one by one. So first operation is facing. So select face operation. Then click on done button. Then click on done button again. Now the tool, select proper tool from the tool library. So click on filter button. So this is different tools like end mill tool, okay, and facing tool, then counter bore tool, countersunk tool. These are the variety of tools. You can select facing tool from the tool library and click on done button. And then next step is select the tool diameter. So now 3 diameter available in our library. So 50 mm, 75 mm and 150 mm available. So you can select any one. So I am selecting here 50 mm diameter. So now next parameter is tool holder. So by default tool holder is on. Okay. So select next is cut parameter. So now this is the stock tool view on floor. You can put as a 0.0 clearance from the floor. Okay. So next is the depth of cut. So 1 mm material remove in one cut. Now next linking parameter. Now the operation start from 2 mm and absolute depth up to 0 mm. Now next is planes tool plane is in top and construction plane is top. Okay. Now you can click on done button. Now if you want to see the simulation, just click on the verify selected operation button. Now see, this is the raw material plate, this is the tool and this is tool holder. Now if I click on play button, it will run the simulation. So now see, in 2 cut, in 1 cut 1 mm material is removed and in second cut again 1 mm material is removed. Now the facing operation is done. Is the next operation is you have to remove this outside material. Okay. So that purpose you can select tool path as a contour. Okay, contour. So select proper chain. Now this selection is counterclockwise direction. Selection is counterclockwise. So you can reverse the direction. It will clockwise chain. Okay. So now select the tool. So click on filter button and select end mill tool. Then click done and then select diameter. So for diameter you can select the select library tool. So whatever in you given in your problem statement, so 10 millimeter end mill cutter is given in your problem statement, then select 10 diameter for flat end mill and then click on the cut parameter, then select the compensation direction, then depth of cut, then linking parameter start from 0 and depth is minus 12 because z direction it is in reverse direction. So planes now see this is the facing operation and next is the contouring operation. See again. Now this is the wastage material. If you want to cut that wastage material, you can add the multi passes. So go to the parameter option, then select multi passes, and the spacing is 10 because tool diameter is 10 So you can add multi passes for 2, and then click on regenerate button. So this blue line indicates the tool path. You can add another pass, then 3, then add another, that is 4. See, okay, and next this is the contouring operation, and next operation is drilling. Okay, in contouring operation there is one important thing, that is compensation direction. Okay, tool nose radius compensation. So by default its left compensation is on. So if you select right compensation, so what will happen after selecting right compensation? See, whatever the required component, that will be eliminated from the raw material. So compensation direction is important. In our theory lecture we have already seen what is the tool nose radius compensation in x direction and in y direction. So select proper compensation